Here are the video solutions for NCFE Functional Skills Maths Level 1. This is Section B, which is the calculator test, and this is the practice paper 2. Okay, so let's take a look at the first question. So what we've got here is we want to work out the volume of a 20 centimetre square tin that is 8 centimetres deep. So the tin, if we're looking at it from above, will be 20 by 20, but also 8 centimetres deep. So the volume is going to be 20 times 20 times by 8, and that comes to 3,200 cubic centimetres. So 3,200. Okay, part B. This is quite a challenging question. So we know from the previous question that 20 times 20 times 8, so the volume is 3,200 cubic centimetres. So we're going to convert that into millilitres, which is a very easy conversion. So that is the same as 3,200 millilitres. So I'm going to convert 3,200 millilitres into litres. Actually, I'm not. I'm going to convert 2.4 litres into millilitres. So 2.4, remember there are 1,000 millilitres in a litre, so multiply that by 1,000 is 2,400. I could have converted the 3,200 to make it 3.2 litres, but this way it will make the next part of the working out a little bit easier. Now this recipe here is for a 3,200 milliliter cake tin. So we know that, and we're interested in butter. So we use 220 grams of butter, and that is for a 3,200 milliliter cake tin. And we've got a 2,400 milliliter cake tin. Now, if it had been, say, 1,600 milliliters, hopefully you know that 16 is half of 32, so it's half the size, so half the butter. So how many times smaller than 3,200 is 2,400? Now, just ignoring the zeros for now, another way we could work this out is, well, 32 and 24 are both multiples of 8. So what that means is both these bigger numbers are multiples of 800. Now, how many 8s? Well, 8 is how many times less than 32? That is 4 times less. So we will use 4 times less butter. And 220 divided by 4 is 55 grams. So we're going to use 55 grams of butter for an 800 milliliter cake tin, but we've got 2,400, and 2,400 is 3 times bigger than 800 because 3 8s are 24, and so therefore I'm going to need 3 times more butter, and 55 times 3 is 165 grams. Quite a challenging question, that one, and there are other approaches, but well, the method I've just shown you was the one that came most obviously to me. Okay, so we want to work out what is smaller, 3/5 or 2/3. So what I would do here is turn them into percentages. You could turn them into decimals, but I find percentages are easier to order than decimals. So to turn a fraction into a percentage, it's top divided by bottom times by 100, so that is 60%. 2/3 is 2 divided by 3 times by 100, which is 66.6 recurring percent. So which is smaller? 60% is less than 66.6%, so therefore 3/5 is less than 2/3, so therefore tin A it will need the smaller amount of cake mix. Okay, if Reg uses both round tins, he will need approximately 5/4 of the cake mix recipe. Reg says this is the same as increasing the recipe amounts by 25%. Okay, so if you're increasing by 25%, remember that 25% is 1/4. So he will need the full amount, which we'll call the 1, plus 1/4, and 1 plus 1/4 is 1 1/4. And 1 1/4, if we turn that into a top-heavy fraction, is 1 times 4 plus 1, which is 5. So 5/4 is what Reg said. So is Reg correct? Yes, he is. Okay, 2E. So Reg is making 24 cupcakes. So if he's using the toppers and he's buying packs of 7, 3 packs won't be enough because that will be 21. So we'll need 4 packs, which is enough for 28. So we'll have some left over. So it's going to be 4 lots of £1.20. 4 times £1.20 is £4.80. So this is the toppers. And for the wrappers, how many packs of 4? Well, that's 24 divided by 4, which is so 6 packs. So that's going to be 6 times 90p, which is 540p, which is £5.40. So that is the wrappers. Which is cheaper? Well, £4.80 is less than £5.40, so the answer here is toppers. Oops. There we go. Okay, Reg buys 24 wrappers, 6 of the wrappers are blue, so what is the probability that he'll pick a cupcake in a blue wrapper? Well, that is 6 out of a total of 24. Now, if you want to turn that into a decimal, just take the top, divide by the bottom. So to turn a fraction into a decimal, top divided by bottom, remember that line of a fraction does mean divide, and 6 divided by 24 is 0.25, which is a quarter. 6 is a quarter of 24. We could have cut this down to, we could have simplified the fraction to a quarter, and then maybe if you'd seen it as 1/4, you might have known to put it as 0.25. Either way, it's still the same answer, but yeah, 6 divided by 24 is 0.25. Okay, question 3. Okay, so he's going to pay back 15% of any income he earns over £25,000 a year. So how much over 25,000 is 27,120? Well, 27,120 take away 25,000, that is 2,120. So he's going to be paying 15% of this amount. So we're going to multiply this amount by 0.15. 0.15, this is the multiplier for 15%. It is the decimal equivalent of 15%. It is 15 divided by 100. 0.15 times 2,120 is £318. So that is his repayment over the year. So what's his monthly repayment? We've been told they're spread evenly over the year, so it's simply 318 divided by 12, and that is £26.50. There we go, 26.50. Okay, Joe has borrowed £1,125. While Joe's at college, simple interest is added to this amount. So simple interest means it is the same interest amount year after year. Don't confuse this with compound interest. So it's 5%. Now the multiplier, so what we need to do is work out 5% of 1,125. So our calculation is 0.05 times 1,125. So this is the percentage multiplier for 5%. And that comes to £56.25. So this is the interest he pays every year. So after 2 years, the interest is going to be £56.25 times by 2, and that is £112.50. So this is the interest he'll pay on top of the 1,125. It does say the total amount, so we want 1,125 plus the interest plus the 1,125, and we get a total of, let me scroll up a bit, that comes to 1,237 and 50p. Okay, so for question 3C, we just need to use this data here to complete this bar chart. Now we can see that we're going to create 3 bars. One is from 2 to 2.99, 3 to 3.99, and 4 to 4.99. So we're looking for any value that begins with a 2. So 1, 2, 3, 4. That's a total of 5. So this bar needs to go up to 5, which is here. So we should use a ruler for this, of course. So there's 2 to £2.99. Let's look for anything with a 3 in it. So 1, 2, 3, just the 3. Yep, just 3. Okay, so that goes up to 3. And how many are between 4 and 499? 1. Just the 1. So the 4 to 499 will just go up to 1, which is here, and we are done. Okay, so for part D, we want to draw in the lines of symmetry. So this is, well, it appears to be a square, and the fact that the dots are 3 by 3 means that the lines of symmetry are the same as the lines of symmetry for a square, which means that there is a line of symmetry vertically, horizontally, and also 2 diagonally, so 4 in total, and you should probably use a ruler to draw those straight lines in. So that's what your answer should look like. Okay, so for part E, which charity is Joe most likely to donate to? Okay, so we're looking at the figures here. Which one has got the greatest number? And we can see it's 0.4, so open line. Give a reason for your answer. Well, 0.4 is greater than all the other probability values, or words to that effect will be fine. Okay, 3F. So for this question, the key thing is that the range is £3.59. Save the Wado has the most and open line has the least. So the range is the difference between the biggest and the smallest. So for the open line, it's going to be £10.50. Take away the range of £3.59, and £10.50 minus £3.59, that is £6.91. So £6.91. Now we know that the total is £35.36. So what I can do here is simply, if I subtract from £35.36, £6.91 and £8.72 and £10.50, or I add those 3 values up and then subtract that total from £35.36, I get £9.23. So the Abbey Trust, £9.23. Okay, so this card here is 29 by 21. We can see that it's longer than it is tall, so this is why this one's the 29, not the and this is 21, and not the other way around. So the height is still going to be 21, but the dimensions, well, it's been split in 3, and so what we need to do is just, well, what is 29 divided by 3? 29 divided by 3 is 9.9. So the dimensions are 21 by 9.9. For part B, what is the total area of the 6 pages? Well, we know one page is 21 by 9.9, so all of that. So this would be the area of 1. So just multiply that by 6 to get the area of 6, and that comes to 1247.4 square centimeters. So 1247.4. Okay, so for part C, we want to draw the plan view. So the plan means we are looking at it from above, so the bird's eye view. So if you're looking at something from above, you have no appreciation of how high something is. So we will not see anything to do with it being 90 centimeters high. All we will see is a 40 by 50. So is the drawing correct? No. The plan view is so the answer is no. So the plan view is a rectangle 50 by 40. The height of, I mean, this is probably more words than we need. The height of 90 centimeters can't be seen from above. There we go. Words to that effect will be fine. Probably could have written that a bit more concisely, perhaps. Okay, so draw a hexagon. So a hexagon is a shape with 6 sides. So just draw any 6-sided shape. It doesn't have to be it doesn't say a regular hexagon. I'll try and this is my best effort at doing a regular hexagon. But yeah, 1, 2, 3, 4, 5, 6 sides. and we are sorted. Now, E is very difficult for me to describe. You are going to have to use a protractor, so you're going to have to sit your protractor there. Should be a tiny little circle which will sit there and get this straight line matched up with the straight line of the protractor, which will sort of be sitting like this. And so we're reading from the left hand side, so we're interested in the numbers 10, 20, 30, 40, etc. Just as a bit of an estimate, we can see that a right angle, so this would be 90 degrees, this is 180 degrees, so it's closer to 90 than 180. But again, if you're using a protractor, you should be measuring that, and you'll see that that is 120 degrees. For part F, what type of angle is that? Well, it's 120, so it's between 90 and 180, and any angle between 90 and 180 degrees is an obtuse. An acute angle is less than 90, a reflex is greater than 180, and a right angle is 90. So here it's obtuse. Okay, so for this question, we can read all the waffle if we want to, but it just says which year had the greater number of visits to the finance page. So last year it's going to be 50% of 25,000. Now remember, 50% is a half. So what is a half of 25,000? Well, that is 25,000 divided by 2, which is 12,500. And then this year, so let me just note that that was last, and this is this year. So this year it's 40% of 32,000. So our calculation is 0.4 or 0.40 times 32,000. 0.4, that's the percentage multiplier for 40%. It's the decimal equivalent. It's 40 divided by 100. That's where that number comes from. And that comes to 12,800. So which year had the greater number of visits? Sorry, I don't know why I thought these were prices. I think I just saw the word finance and thought it was money. So let's get rid of all these pound signs. It's got nothing to do with it. It's just number of visits. So we can see that 12,800 is greater than 12,500. So the answer is this year. Okay, so for 4H, it says give 2 reasons why the bar chart is inaccurate. Okay, let's compare this to the data. So, sorry, which year was it? Did it say? It says last year. So it should be 50, 20, 25, and 5. 50. Okay, this should be 20, 25, and 5. So as it is, well, the well-being, you can say they don't add up to 100%. Or well-being is 10%, not 20%. I'll do that. So well-being should be 20%, not 10%. Okay, so I'm looking for another problem. Let's just have a look at the side here. 0, 10, 20, 25, 40. So this should be 30%. So we can say the vertical axis is incorrectly labelled. And 25% should be 30%, or anything that conveys that message. Okay, and for part I, there is an even chance. So if it's an even chance, that's a 50% chance. So the probability is 50%, or 1/2, or 0.5. So if this is a scale of 0 to 1, we just need to find 1/2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I had a feeling it would be cut into 10. So halfway along would be 5. So 1, 2, 3, 4, 5. So that is the probability. So we can see it's halfway along the line. And there we go. That is the end of this assessment.